Good morning, grade 9. Good morning, my advisory. I'm happy to see you now. And we need to continue with the discussion. Of course, this will be uploaded in your LMS and activities are in the LMS already. Okay. By the way, for the activities, I actually didn't put any restrictions to them. Why? Because I understand the need. I understand that we need to cope up. We need to recover um, with this scenario, with this scene. Okay. Let's move now to volcanoes. What's in the volcanoes? Why do we need to know about volcanoes? How do these affect our daily lives? These are just few questions that might answer, that might discuss during the discussion. What else? What's inside the volcano? How do this volcano work? Okay, let's move to volcano. Volcanism is one of the primary geologic forces that continually alters the Earth's surface. Okay, it is described as movement of molten rocks beneath the Earth that is responsible for volcanoes. It produces changes caused by forces arising within the Earth's crust. By the way, it is the primary geologic forces that continually alters the Earth's surface. What does it mean? Why do you think so that Earth needs to be altered? Okay? Altered meaning change. Okay, any idea? Why it needs to be altered continually? Any idea?
For ventilation.
Ventilation? Any idea? Yes? Why do we need to alter? Okay? Why Earth needs to be altered? What's with the alteration? Okay, let's change the word alter into change. Okay? Why Earth needs to be changed? Okay? Number one, this is because of what? This is because of evolution. Okay? And of course, because human also evolves, okay, there are a lot of activities that affect also this, right? Again, if you're going to look at the Earth's Earth's core, the inner core, okay, there are three cores of Earth, correct? Are you familiar with this? Did you discuss this in your previous
Yes.
years? The inner core, okay,
Yes.
the middle core, and the outer core, okay? These cores, if you're going to look at it, it comprises of what? The Earth's core, okay? Aside from that, Earth is divided. We are talking about core a while ago. Earth is divided into three also. Okay, we have the crusts, which is the outer part. Okay, which is the biosphere is actually located. When you say biosphere, this is the layer of Earth that comprises of life. Bio means life. Okay, the crusts, the second layer. Below the crust, we have the mantle. Okay, and of course, the last one is the core. Okay, the core is divided into three. The outer core, the inner core, the outer core, the middle core, and the inner core. Okay, because of this core, because of the heat, okay, from the cores, this core, it produces a massive, okay, it produces a massive pressure. This pressure should be released in the surface of the Earth, and it actually causes movement, right? Magma associated with explosive eruptions, okay, or eruption may be 5 times more viscous than magma, okay? Viscous meaning, the vernacular word for viscous is lapot, okay? That is extruded in a quiescent manner. A volcano is an example of extrusive volcanism. When you say extrusive, okay, when volcano volcanic activity takes place above the ground, okay? So that hot molten magma is released into the landscape. We say that the volcanic activity is explosive, meaning to say you can actually observe it in the what? In the ground, okay? If it is observable in the ground, it is explosive. Okay, meaning it is on the exterior or outside the crusts. Okay, but if, okay, take note, if the volcanic activity is inside the crusts, okay, there are a lot of cases that volcanic activity is inside the crusts. One good example is the seafloor spreading near seamounts. Okay, this is the reason why your seafloor until now is expanding, still expanding. Why? Because there are a lot of volcanic activities beneath seafloor. Okay, so if the volcanic activity is beneath, okay, the crusts, it is called intrusive. Okay, let's discuss it later. Extrusive volcanism is a phenomenon that takes place when the magma under great pressure, okay, with molten material forces its way through the fissure or fissure. Are you familiar with the fissure? It's a crack of the underground rocks and reaches the Earth's surface to form igneous explosion. Okay. Again, if these molten rocks cools down, it actually create, or we can actually create, or we can actually observe an igneous rock. Okay. Extruded materials include the molten materials that reach the surface of the volcano. This volcanic activity is also known as surface volcanicity. Okay. Please take note of the terminologies, right? This might come up in your exam. Your third mastery test is fast approaching, as well as your third periodical tests. Intrusive, the one that I am telling you a while ago. Okay, intrusive volcanism, on the other hand, is when the magma is forced into the rocks that make up the Earth's crust. Okay, it occurs when there are lines of weakness such as faults, joints, or bedding planes in the crust. Okay, the magma enters these weak lines or lines of weakness when it cools and becomes solid while still underground. So if it is not actually released in the surface of the earth, therefore this is intrusive. Okay. When it cools down and becomes solid while still underground, different features like plutones, dikes, sills, decolits, batholiths may be formed. Okay, the rock form is an intrusive igneous rock, still igneous rock, because again, when magma or lava cools down, okay, it actually creates what? An igneous rock. Let's move now to volcanic eruption. Do you have any questions so far? Questions? Are we all good?
None so far, sir.
Okay. Actually, I'm really happy to see you, all of you. Okay. Hopefully, your other classmates can join. And aside from that, offline learners, Rabi, please take note. Offline learners, I already given them a lot of chances. I actually submitted as early as possible my modules in school so that they can actually pick it up. Okay. And aside from that, let's help your classmates, Rabi, especially those that are really affected. Okay. We are all affected, but there are few that is really devastated. Okay. I'm talking about the effects, right? Emotionally, physically, spiritually. So let's help them out, right? This is not a time for competition. Everybody, is that a deal?
Yes, sir.
All right. Volcanic eruption.
I'm also using modules, sir.
Are you using a module, Janine?
Yes, sir.
Yeah, that's why I added actually two in the sets of modules. Did you receive the module that I already printed out? Printed?
I've already answered all of the activities.
That's great. So how many activities are there? I think I already given around 3 activities for a month, correct, Janine? Am I correct?
There's only these.
Come again? Come again, Janine?
Two activities, sure.
Yeah, 2 or 3, I think. So most probably it is manageable. And of course, I am considering also the other subjects. Okay, that's one way for me to help you out. Okay, let's move now to volcanic eruption. Okay, most magma is generated by partial melting in the upper mantle to form molten materials having basaltic, andesitic, or rhyolitic composition. If you're going to look at these compositions, okay, this is really quite interesting simply because um, you might think about how do these actually form, okay? These are minerals. Okay, how do these actually form? And this is the reason also of the birth of your diamonds. Okay, again, your diamonds is created because of pressure. Okay, your diamonds is created also because it is actually stuck for a longer period of time in a high pressure, and it is actually what? 100% carbon. Okay. Once formed, the buoyant molten rock will rise towards the surface because the density of the crustal rocks decreases. Okay. The closer they are to the surface, ascending basaltic magma may reach the level where rocks above are less dense. So it will actually what? Go into the level. So remember the 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 flow, okay, going from the concentration gradient. Are you familiar with the concentration gradient? Did you discuss it in your previous years? Concentration gradient.
I don't remember.
Okay. This is actually discussed during grade 6. Okay. You are actually using what? A colored um a colored water with food coloring. Okay. You are trying to transfer the water. Okay. You're trying to transfer the water on the other container using a tissue paper or a cloth. Okay. That is actually concentration gradient. From greater concentration to lesser concentration. Okay. So the movement is from greater concentration to lesser concentration until such time that it will actually go in the same level. Did you get my point? Do I need to um
Yes.
do I need to convert it into vernacular? Everybody? So this is the ascending basaltic rock magma. Okay, because the two, okay, densities of crustal rock decreases, okay, the basaltic magma may reach a level where rocks is less dense. So meaning it will go on the same level until it reaches on the same level. Okay, that is actually the concepts of concentration gradient. Okay. Should this occur, the molten materials begin to collector pond, forming magma chamber. Okay, remember your magma chamber? Okay, I think I have an illustration here. So your magma chamber is in here. Okay, this is your magma chamber. Okay. Okay, this is your magma chamber. This is your vent. Okay. It is actually collected in the magma chamber. As the magma body cools, okay, the materials or the minerals having high melting temperatures crystallize first, leaving the remaining melt enriched in silica and other less dense components. Some of these multi-materials may ascend to the surface or may ascend to the surface to produce a volcanic eruption. In most tectonic setting, remember the tectonic plate theory, okay? We are actually what? We are actually in the tectonic Philippine plate, okay? Based on tectonic plate theory. Some of these multi-materials may ascend to the surface to produce volcanic eruption. In most tectonic setting, only fraction of magma is generated to a depth, or at a depth even reaches the surface. Okay, if you're going to look at this, okay, this is your magma chamber, the conduit, the vent, okay, the side vents, meaning to say the release of pressure. And take note, this pressure should be released, otherwise it will actually what? Erupt in an explosive way. Okay, so there are a lot of eruptions. Let's take a look at later what are these eruptions and what are the effects of these eruptions. Volcanoes are classified as active and inactive or dormant. Okay, active volcanoes are those are currently in state of regular eruptions. Can you name one active volcano in our country? One active volcano in our country, everybody?
Mayon Volcano.
Mayon. Yes. Mayon is an active volcano. Correct. And based on its form, Mayon also has a complete, or has a perfect cone. Okay, let's take a look at what kind of volcano Mayon is. What else? Any other volcano in the Philippines? According to the studies, that Philippines belongs to, or in the Pacific Belt Ring of Fire. Because we are in the Pacific Belt Ring of Fire, we are located in the Pacific Belt Ring of Fire. There are a lot of volcanic activities in our country. Also Japan. Okay, Japan also lies in the Pacific Belt Ring of Fire. So what other volcano that you can observe, which is until now active? How about Taal? Is Taal active or inactive? Taal volcano. The volcano with the lake, Lake Taal. Before, it is actually inactive, but now it actually changes its state to active. Okay, active volcanoes are those that are currently in the state of regular eruptions. It is maybe going off right now or had an event in the last few decades. Further, a volcano is classified as active volcano if, at the present time, it is expected to erupt or is erupting already. Okay, take note that these states, okay, inactive or active, might change from time to time. It depends upon the pressure beneath the Earth's surface. Okay. Dormant volcano is one of the, let's move now to dormant volcano. Dormant volcano is one that is capable of erupting, okay, and will probably erupt, or probably erupting, and will probably erupt again in the future. Okay. But it hasn't, okay, or it has not had an eruption for a very, very long period of time. Inactive does not necessarily indicate the volcano will not erupt again. Okay, this volcano is also expected to have an eruption sometime in the future, but you cannot actually tell. Okay, that's the difference. Okay, let's move now to the types of volcanoes. Okay, there are a lot of types of volcanoes based on their form and based on their behavior. Okay, the way they erupt, the flow of the magma, okay, which actually can create, okay, can create different landforms and can also affect different lives living there, okay, living near the volcano. Shield volcanoes, okay, they are produced by the accumulation of fluid basaltic lavas. Fluid basaltic lavas, meaning to say, if it did not actually reach the Earth's surface, it is usually termed as lava. Or again, if it actually flows outside, okay, again, come again. If it is actually flows outside, okay, it is actually called lava or the lava flow. Okay. Again, this is produced by the accumulation of the fluid basaltic lavas and exhibit the shape of the broad, slightly domed structure that resembles a warrior shield. Okay. If highly fluid lava is exploded, the volcano takes a broad shape and slightly domed structure that resembles a warrior shield. If you're going to look at it, it looks like a dome. Are you familiar with a dome? It looks like a
Yes,
dome.
sir.
Okay. It looks like a shield. Okay. This is because of the lava flows. Okay. Pyroclastic materials are clouds of ashes, fine dusts. Take note that these pyroclastic materials and ashes can actually affect your lungs. Okay. Volcanic bombs and blocks of lava fragments that are carried through the air and the vapor. And aside from that, it also carries with a chemical, okay, which can actually again affect your lungs. So this is the reason why. This is the reason behind. We need to know, okay, the different types of volcanoes. We need to know the eruption of these volcanoes and the effects of this, okay, if in case there is an eruption, and what are the things that we need to consider in order for us also to evacuate in certain areas to make ourselves secure and even our family members living near the volcano. Okay. Okay, if you're going to look at this, this is the shield volcano. Okay. Because the eruption here is silent, okay, silent eruption, there is a lava flow. To take note again, if the magma reaches the Earth's surface, okay, it actually creates a lava, or the term now is lava. So it will actually solidifies. Why? Because if you're going to look at magma chamber or magma, it is really hot. And the atmosphere, if it is released in the surface of the Earth, is cool. Okay, it has a lesser temperature compared to the magma. So it will actually solidifies and cools down. So if you're going to look at it, it actually forms a dome. This one. So this is a shield volcano. Do I make myself clear?
Yes.
Everybody can hear me?
Yes.
Okay.
Yes.
Cinder cones, also called as soria, okay, soria cones, are built from the ejected lava fragments that form cinders or clinkers as they begin to harden in flight. Cinder cones, okay, have a very simple, distinct shapes determine the slope that loose pyroclastic materials maintains as it comes to rest. Okay, this is the cinder cone. As you can see, again, these are the pyroclastic materials in here. Okay. And it actually looks like a cinder, a cone. Okay. A soria. Let's move now to composite volcanoes or composite cones. Okay. Composite cones are also known as strata volcanoes. Well, your Mayon volcano is actually one of the example of this strata volcano. Make up some of the picturesque, okay, meaning to say most picturesque. It is actually observable in your catalogs because of their form, distinct form, because of their beautiful formation, okay, known as volcanoes that we have on Earth. The composite volcanoes usually made up of several layers that harden lava and volcanic ash from explosions that have already taken place. This is normally why they can make such peaks because of constant overlapping that takes place. So it overlaps, cools down, overlaps, and cools down. So because of this constant overlapping, okay, we can actually observe, we can actually have a perfect cone. Okay, we consider this composite volcano or composite cone or strata volcanoes as a perfect cone. These volcanoes usually erupt violently and have the higher numbers of casualties than the other volcanoes. Violent eruptions. If it is a volcano that has or that is being noted to have a violent eruption, tendency is we need to be extra careful. Again, evacuate as much as possible um when there are some cases of smoke, okay, coming out in the cone or coming out in the vent of these volcanoes. Okay. As you can see, this is your Mayun volcano while erupting. Because of this strong eruption, okay, because of this violent eruption, tendency is it has a what? A perfect cone, okay, perfect form. This is now your what? Composite cone, okay. By the way, do you have any questions so far?
None.
Okay, this lesson was actually introduced during grade 6. Okay, this is actually introduced during grade 6. And of course, in your higher years also, you'll be discussing also this one, even in the senior high. Okay, under earth science. Other volcanic landforms, you have calderas. Okay, have you heard about calderas? Caldera. Okay, a caldera is a volcanic feature formed by a collapse of volcano into itself. It actually collapses to itself, okay, making a large special form of volcanic crater, also known as a bathtub volcano. Why bathtub? Sure, because again, the volcanic crater, the crater itself, the vent itself, actually collapses to itself. While because of this collapse, it actually forms because this collapse forms again a bathtub volcano. It looks like a bathtub actually. And the temperature there, take note, the temperature there is still high. Hot springs, okay, these are created because of this volcanic activity. Calderas are large depression with a diameter that exceed 1 kilometer and have somewhat circular form. Of course, because your volcanic crater is into circular form. We still have 2 minutes and 43 seconds, but I think we discussed a lot. Let's continue the discussion by next meeting. We already discussed, again, the different types of volcanoes, okay? The volcanic activity, the movements of plates because of volcanic activity. And I will elaborate more about these volcanic activities by next meeting. Do you have any questions so far? Questions?
None.
Right. Am I clear in your area? How about my audio? Can you hear me loud and clear?
Yes. Yes. Yes.
Sometimes you get cut off.
Again, Janine, come again.
Sometimes you get cut off, sure.
Oh, all right. Maybe the internet connection. I'm sorry for that. Anyway, again, we'll be having the discussion by next meeting, hopefully. And afterwards, I'll be uploading this in the LMS. Rabbi, can I ask a favor? Please inform your classmates, those who are not around, that I'll be uploading this in the LMS. Right? Rabbi?
Yes, sir.
Okay. I think that will do for today, class. Again, thank you for your participation. I am happy to see you, everyone. And hopefully, your other classmates can join the next meeting. Right? Do you have any questions so far? Questions?
Answer.
I think that will be all for today, class. Have a nice day, everyone. Take care. Bye-bye. Keep in touch.
Bye, sir.
Bye-bye.